Okay, we're in this video I'm going to describe the orbit or Lissajous plot. So first thing is to create this plot, to get it so that you can click it here. It's disabled. You need to select a regular channel, and then in the x-axis data area you have to pick another channel. It could be the same channel, but likely it's going to be a different channel. So now this is now enabled and we can create the plot. Now, let me make two other plots here so you can see what the other channels look like. So I created one for time plot for the other two. Actually, let's do it like, let's put two traces on the plot, put it here, and then we'll go like that. So now what we have are a regular time plot with both channels on there. You can see they're exactly the same signal. And then we have this orbit plot where it's plotting, really what it's doing is it's on the x-axis, it's taking each point, the first point from channel 1 and the first point from channel 0, and it's using that to locate the first point where it draws a line here. And it does that for all the points. So when the signals are perfectly in phase, you get something that looks like this, which is a line. Now these are actually drawn, if you zoom in, this is fixed for right now, but these are actually drawn as little hash marks, little lines. So that's why it looks, it's a wider size line. Now, what you can do is, I'm using a simulator, but using a real signal, if the phase, what this will show graphically is phase differences between two channels. So if I pick channel 1 and I take the phase and make it 90, you can see now it looks more like a circle. It's kind of distorted because of the scaling of this plot. We can see that it changes it that way. And you can, as you sweep it around, you can see how the phase change between the channels is being represented in the orbit plot. So you can see the time domain signal shift. It's showing that phase difference. So when they're lined up, it's a line, and then it completely out of phase, and it comes back and goes the other direction. So it's really the angle of the line is indicating the sign of the phase. And then, so it also, the frequencies are exactly the same, but if you change, we can put the phase back to 0. And if we start rolling the frequency up, you start getting some really interesting patterns. Some of them I don't know how you decipher them, but this is kind of what it would look like with a sine wave. Things like that. So that's the orbit plot, or Lissajous plot. Graphically shows phase differences between two channels.